Hello, hello. Yes, the microphone is now on. The microphone is now on. It's very good. So, we have this renderer in a new game engine, in a new programming language that got booted up from nothing, and we were building it, as we were figuring out what the game should be and all that. And just over time, it has, as software tends to do, accrued like layers of stuff as we were just figuring out how to do everything. And the thing is, I would like for people to collapse layers, but they don't seem to ever frickin' do that. And so once in a while, I just have to step in and start doing some of that. And so I'm going to start doing some of that. I did some of that actually a little bit earlier. There's this really goofball thing going on. Where like, how does data get to the shader? We fill out this entity parameter struct. And then this other thing, this thing actually makes a rendering component that's full of the variables. You'll note that it sets all these fields by string name, which is something we're going to fix today, right? And then, like, there's just a lot of layers of crap happening just to draw anything, right? And a lot of it is unnecessary. And so I'm busy. I have too much to do in life, but I can't get anyone else to do this stuff, so I have to do it. So we're going to start fixing these things. I shouldn't be too grumpy about it. I mean, people are doing stuff on the game for sure. It just sometimes it gets to be too long on some of these things. So, could be worse, could be Vulkan. I mean, yeah. Anyway, so what I want to do right now, I'll tell you what I did last time, or this morning, or yesterday, something like that. Yesterday. We used to do this add component by string name. And what a component is, it's just a constant buffer. I don't know why we call them components. I mean, yeah, anyway, it's just a constant buffer with the constants in it, right? And, well, we used to be even looking that up by name. And the thing is, this gets called once for every entity in the game. And we don't draw tons and tons of entities in this game, but we might draw like, I don't know, 6,000, 8,000, 10,000 per frame, right? And, well, when you start doing all this stuff, like it adds up, right? And the way that I ended up in this function was I was testing some compiler stuff, and I just randomly just said break now in Visual Studio, which is actually an underrated way of knowing what's slow in your code, because you probabilistically end up wherever is doing work. And I ended up here, and I looked at this, and I was like, why are we doing this? This constant buffer is constant at compile time, or at runtime. It might change if we hot load it, which is a developer thing about editing shaders and stuff, right? Obviously, if you edit a shader program, the constants in the program might change. And that's great, but you don't need to think about that for every single entity inside a frame. So, and we have a particular piece of code that at the beginning of the frame goes and handles hot loading and reloads the shader. And if you need to change what the size of this buffer is or something, you do it at that time, and then you don't worry about it for the rest of the frame. So I changed this. So we no longer look up this component by string. There's a global now. Some people will tell you global variables are bad. They're not bad. They're bad if they're bad. And this one is good. So, yeah, so I did that. And then I noticed this, and I'm like, oh God. For every single entity we render, we're doing a minimum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, like 24 variable sets by string, which involves hashing the frickin' string, looking it up in a hash table to find some address, and blah, 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 right? And again, that's constant per frame. Anytime you multiply something by like a factor of 20, even something that's kind of fast all of a sudden becomes kind of slow, right? Like imagine your 4 gigahertz CPU was suddenly a 200 megahertz CPU. That's like a factor of 20, right? So once you start getting up that, and that's to do anything, that's to render any, and this is in addition to all the actual useful work that's being done. And so it's time to just attack this with a machete and cut it down. Could you replace it with compile time hashing? Not really, because then we wouldn't really be supporting hot loading, right? I mean, okay, well, you could map this string to an integer, but then you would still need to be looking the integer up in the hash table and all that, right? And we shouldn't have to do any of that, right? All we should say is assign this field to this value. This should be an equal sign, basically. And instead, it's almost like we're programming in Python, all this crap we're doing. Actually, we're at least 10 times faster than programming in Python still, but nevertheless, this is not something you want in the middle of your renderer. Now, this is just one layer of a problem that's going on. There's this entity component param struct. It's like some other struct that we fill out. Why? We don't need to, right? And then that is filled out based on some other fields on the entity that are already stored. Why, right? Like what we should be doing is creating this constant buffer and then putting the values in the constant buffer when they're computed once per frame. And so there's several layers of indirection or wrappers around wrappers to be folded up, right? And I'm going to hit one of them right now. I can't do all of them tonight, but the line must be drawn here. Do you know what I'm saying? The line must be drawn here. Okay, so what I'm going to do is I'm just going to make a struct that contains one member for each of these, right? And then I'm going to replace this. I don't know about set texture. We're going to see that. That's probably the same. I just need to look at what that is. But set constant, we can look at that. All right. Okay. So what set constant is going to be doing, right, is it's going to take this string. It's going to be hashing the string, looking it up in a hash table to find some record. I hardly ever look at the rendering code, so I don't know what it is, but it's going to find some record of what is the offset and size and maybe type of this thing inside this constant buffer, right? So instead of doing all that every time, we're going to do it once and store that in a struct. And then here, we're going to do a much cheaper operation that's just like probably casting to the thing. All right, let's find it. And there's all these like frickin' overloads of set constant probably for every data type. And like, we don't need them. Okay, so let's find that. Let's find that. So already we have in two different files, we have there's a shader instance, a shader component instance, and a constant buffer instance. Okay, so there is something called a constant buffer that's different from a shader component. Like why? I don't fucking know, dude. Like by the time I'm just going to revisit this once in a while, and by the time I'm done with it, there's going to be just like several fewer things. I think there's just too many things. All right. So what is this? This is probably a component instance. So we're going to go look in this. Add constant. No, what is it called? Set constant. Set constant. Hey, look, it calls set constant on the constant buffer. It's like, what? So, okay. So the first thing we're doing is calling shader param hash. All right. So the overload. Okay. And see, I already don't like this because this assumes there's no hash collisions. Like what? Because if you don't pass the name, Okay. Amateur hour. Okay, so set constant in the other file is in the shader binding model. Okay, so this also has a string overload. And then this has a location, which is a U32. It's a U32, and we're assuming it doesn't collide. Like, bro. Okay. Yeah. All right. So this, okay, so this thing is a record that has a type. It has a offset and a size and also an array count. So this is actually what we want. We just want this, and then we want to use that to set the thing. Okay. All right. So any libraries for tensors, ND arrays, e.g. a shape of 64? No, why would you do that? Why would you do that? Okay. Is location an actual hash, or is it already the location? No, it's an actual hash. So we're looking that up in the table and then finding the index. And silently failing if it's not there. Like, oh my God, dude. Oh my God. It just... All right, it's too many things, like I said. Okay, so here's what we're going to do. I'm just going to start typing it at the bottom of this file, even though we're going to move it around it a little bit. Actually, no. Let's go back over here. Let's find out, actually, what is the type of this thing. Constants. Constant buffer mapper. Okay. And then constants is an array of constant. Okay. So we want a pointer to a constant. It's like, dude, all this is such a waste to have all this code. Never mind. I'm not even going to say that. I'm not even going to rant about that. This is all just a stupid artifact of the fact that we can't just run regular code on a GPU for no reason. All right. So here's what we're going to do then. We go back here. Boy, I'm even grumpier than I'm grumpy because I'm not grumpy. I'm in a good mood because I finally get to clean up, or I see the pathway to this many steps of cleaning up something that's been bugging me for a long time. That's great. I'm grumpy because none of this should be necessary in the first place. I don't know why I have to do all this. It's all just like totally... Like what we have done in the games industry is create a giant goofball waste of time. But at least it's not as big of a giant goofball waste of time as what the web people did. So I guess we're still winning. All right, so we're going to make a struct that just has a constant for every single one of these. All right? And that also has the bonus that we get compile time static checking on these members. Like if you try to set a constant that doesn't exist, it'll say, hey, man. All right, so... entity params constants is a struct And it's literally going to be just a bunch of these. Boom. Right? Okay. Is neg scaled? Entity color, effect color, mesh center, entity random, mesh extent, mirage on T, mirage clip. So we've got a few of these. Point, enabled. Look at all this crap for mirages. Light map params. Invalid T is reflecting. Discard plane. Discard is active. Wrapping offset. Like I said, we're going to think about the texture slots and stuff separately. We're going to make it work with all this. This is a massive number of string ting-tanglers that we get rid of. And I'm going to like do some crap here. Right? I mean, the line must be drawn here. It's really interesting, like just code that's formatted in an ugly, hard to read way is usually also not good code, because it's just a sign of how much effort somebody's putting into what they're doing. Okay, so we have this, and now we're going to make a function that looks these up. We're going to have refresh constants, all right? And it's going to be target struct is something. We don't know. It's going to be this, or see, this would be pointer to any params constants, but we're going to reuse this function for a bunch of different things, right? Okay, so we're going to refresh the constants, and there's going to be, you know, like the something, I don't know what this is yet. I forgot, so we're going to look that up later. But this is like the shader that we loaded, and then this is the struct that we want to fill out. And we're going to say ti is type info t, assert ti dot type is equal to dot struct for member ti dot members. Okay. It has a name, and you know what? Let's just, okay, let's start doing the work, and then we're just going to hook it up and then do the rest, right? So we're going to go hash is shader param hash name, and then index found is table find cbi.constant buffer mapper.map hash. All right. And then if we didn't find it, we're not going to be silent, right? Silence is violence. We're going to say log error. Unable to find this name in refresh constants for whatever. Okay, name and t. All right. And then continue. If we did find it, we're not going to do anything. Oh, well, I guess we'll just set it, right? Index. And then we're going to say so we're going to have a base and we're going to say base plus member.offset in bytes. All right. We're going to say assign there. Okay, so we can't quite even try to hook this up because we don't know what this thing is. So here, we reload component if dirty. If we reloaded, we're going to say I want to name this like in parallel. So we're going to have some variable called I wanted to say shader constants. I don't know. We're going to say refresh constants on this. I'm going to say move this to somewhere. Constants for any parameters C. What was the other file we were in? Shader component, right? .cb. I don't know. Okay, I'm getting behind. Let's. There's too many things flying around. Okay, so this thing we're going to put down here. Constants for entity parameters C is entity params constants. Okay. We're going to get the pointer up here. We'll stuff null in it or the value. Okay. So we fill this out. When I said reloaded, I don't know if this returns true or not. So we need that. Reload. So bright component if dirty. Shader catalog. Reloaded is a bool. Return true. Okay, this is a problem now, actually. Fuck. The problem is a lot of places call this Okay, you know what we're going to do? See, if you do this like in the middle of the frame, it's really not a good idea to do this in the middle of the frame, because like some data could be going, I don't know. One battle at a time, folks. So a lot of people, like, why do we have these fucking everywhere? It's banana cakes. What we should just do is have a loop over all loaded shaders, because the shader catalog knows what they are. All right. So for now, okay. Replace all the reload if dirty. Okay. So we need to return false here. Okay, so okay, it's going to be fine. We're not going to worry about the dirty thing yet. And in our definition of refresh constants, I'm actually going to print found I just want to see success, you know? All right, how many mistakes? Oh, let's not even make a release build. That's bad. Undeclared identifier constant. Okay, well, that must be a frickin' thing. Constant buffer mapper dot constant. Okay, we're going to say, where was this again? Render frame. I just don't want it to be that long. Entity params constants. Oh, because I replaced this. Oops. Oh, shader component thing. This is constant buffer instance. All right. I think. Oh, that's not a component. It's not a component. See, there's like a shader file, but then there's a shader, and there's like, There's too many things. Okay, so okay. So this actually, I think, returns a shader component instance, which, why is it called get shader component? Like, right? There is a thing called a shader component, but this is getting a shader component instance. No, it's returning a shader component. Okay. Okay. That's fine. So where's that? It's called shader. Okay. Okay. Like, by the way, guys, all of this is just so we can run code. By the way, do you know what computers do automatically? They run code. But somehow we've made it incredibly Byzantine just to run code. Your CPU doesn't know how to do anything but run code. All it does is run an instruction and advance the program counter. And somehow we've turned it into this, right? Oh my God. All right. So okay. So I'm just looking for what is the like, I have to backtrace now. Like, where do the constants get loaded? Because I don't see constants here. I see shader parameters here, right? I see shader parameters. Like, sure are a lot of members here, but okay. Type, array count, name, offset. Oh, okay. So this is really, like, the constant is probably just a redundant copy of this that's not even fucking necessary. But we're going to have to trace that down as well. Okay. Yeah, there's just, guys, it'll make your life. The one thing you can have as a programmer in your career is a bias toward simplicity. And that doesn't mean not doing work that needs to be done or not attacking complicated problems. It means after you attack the complicated problem and you have something with a lot of moving parts flying around, just see if you can reduce the number of moving parts flying around. It'll make you happier. It'll make everybody happier. Everything will be great. Okay, where did constant live? We have to trace this backwards. All right, so shader binding model. Okay, type. Right, so then we have constants here. Now, why this is separate from the shader parameters, I have no idea. Maybe there's a good reason, maybe there isn't. I don't feel like there's a good reason for not at least sharing the data type, but whatever. So who refers to this array? We init a constant buffer mapper. I'm going to correct all our else statements. As soon as I start taking some degree of ownership of code by doing a cleanup pass on it, I'll change the else statements. Don't you worry about that. Okay, we're saying add member to a build buffer context. Like what? So this is when we get a declaration. We're adding one of these. How much code? It's not 900. It's not that bad. Build buffer. Like there's so many things. They don't fit in my brain how many things there are. This is all just to run code. That's all it is. Shader code question mark? What's the difference? How is shader code different from regular code? Does it not run on a computer? Okay, it shades. Good answer. So we're down here at these set constants that we were looking at. I don't know how to get so the constant buffer instance has a constant buffer mapper, but I wouldn't expect the instance to have its own map, right? Like if you have an instance of something, that usually the schema or whatever describes how things are stored is in the parent struct that the instance is an instance of. So this is confusing me already. Constant buffer instance. Okay, so it's got a pointer to somebody else's constant buffer mapper, right? Allocate constant buffer instances. Dude, I'm lost again. All right. S.constant buffer map. Okay. Okay. That's actually okay. Constant buffer mapper. We probably want to take the address though, just because we're going to do that. Right? So then this is going to be just mapper. Mappy. Remember the arcade game Mappy? I never played it. I don't think, hardly. If reloaded. Ah, wait. I thought I saved that. If dirty. Reloaded bool. Oh, reloaded. Oh. There's just too many things. Okay, now what? It.name. Oh, because I didn't say member. We're down in the simpler situations. Okay, constant. No, that has to be whatever constant. CBM constant is the horrible name we picked for that. This is mapper again. Mappy was sick. All right. Hey, look, it runs. So we should be able to run the game and see some printf spew. Now, the actual setting of the parameter still hasn't changed. That's still setting by string. All we've been doing is hopefully setting up the constants. Okay, you know what? I bet we're returning false that it wasn't dirty because like I said, there's maybe multiple places that load it. And if a different place loads it, you know, so we're just going to refresh the constants at the beginning of each frame. Have I done any hexagon tile systems? Not really. So now, okay, there we go. We're spewing every frame. We're looking up the constants. We're finding the constants. We're not finding any errors. How baller is that? Okay, so now we get to do the actual thing. All right. And this causes us to not have a clear picture of when it needs refreshing. This ought to get fixed. Okay, so here's the thing. Let's just replace the first thing manually. What was this function? Here we go. I'm going to put a no check in here so I can find it. All right. So now I'm going to say C entity parameters C. All right. So now if we don't have an overload of set constant that takes a constant, then we need one. But here, I'm just going to go, we're actually going to, do it step by step, right? Okay, so set constant CI c.normalxform, right? So this is now a static name that our compiler understands. And it's also a frickin' pointer to a data. We don't have to hash table or nothing, right? Okay. Okay, so what was the shader binding model? Okay, constant buffer, location. We get this constant. CBI.constant buffer set. Like we do 2 mem copies, which is freaking stupid as well. Like why? Why? How is Babby formed? But we're just gonna, again, one battle at a time. So the whole thing is it's maintaining like a CPU copy and a copy to go to the GPU, I guess. But like, just fill out the whole thing and then do 1 mem copy of the whole thing. Why are we doing 24 mem copies? 24 extra mem copies. You know what I'm saying? So, no, we're doing 48 mem copies per entity at least, right? But 24 of them are like, yeah. Don't worry, we're going to be getting rid of all this eventually, but again, one battle at a fucking time. All right. So we're just going to go all the way back here, and we're going to say set like, why do some of these take pointers and some of them don't? It's because, so some of these are like a vector AP, like they're doing this thing where it's like there's an implicit argument of one or more about how many items are there, but that doesn't exist for like the Boolean ones. And it's like just, so we're going to do this. All right. And we're going to say so T was like let's just do this. So we get the type in that way. We get the pointer. You know what, this doesn't have to be a macro, it could be inline. Okay, so at least we will have turned all of this stuff, all of this hash table lookup and stuff into just this, which is still too much, okay? And we're going to get to that later. But, yeah. So, oh, but this is not even, we're not doing like frickin' index here. We're mem copying pointer, value pointer, count is just 1 here. If you want a vector version, we can deal with that later. We almost never use that. This is not necessary. This is not necessary. Although actually, let's just do this. And I hate putter, by the way. The line must be drawn here about putter. All right. So that's what this looks like. And we say set. This is a shader component instance. And instead of dereferencing that a billion times, we'll get it. Type given constant buffer instance. All right. You know what? We'll just I'm a little bit skeezed about this not being a pointer in terms of long-term maintainability. So we're gonna do that. Oh, whoops! I put the star. I put the star in the wrong place. All right. How do you transition from being a worthless web dev into a useful member of society while still supporting my family? The highest paying jobs are not web developer jobs. You can make $4 million a year being an AI programmer right now. Now, most of those are script kiddies, but still. You could easily make 700, 800K doing like financial whatever the fuck, right? Like, web dev jobs are pretty low on the totem pole salary-wise. They still get paid ridiculously much, but like, dude, just go be a game engine lead at a game company. You can make $1 million a year at one of the AAA companies. I can't afford to pay people that. Maybe someday I will be able to. Yeah, like, no, the amount of money flying around is insane. Hey, look, though, we're rendering correctly. You know, we're getting 20 FPS right now. This is a very debug build. We could actually do LLVM debug build and just see what the FPS is, and then see if it's a noticeable improvement when we're done. Even if it isn't a noticeable improvement, actually, we should go to a different level to do that. We should go to a level with like target graphics that are something like final target. So like, we should go to maybe promised one, right? Oh, I forgot to take out those print statements. Oh God, those are going to make us really slow. So no wonder we're only getting 20 FPS, even if it is a debug build. Render frame. What? Oh, because it was in here. So we just take this out, and that'll get rid of the spam. Is there a difference between debug and very debug? There isn't. Well, it depends on if you're talking about for the compiler or the game. For the compiler, there isn't. I had meant there to be. I wanted there to be some basic amount of optimization in debug that still doesn't really interfere with debug info, but it was very hard to get LLVM to do that. But in our own backend, when we start doing optimizations, which we might do soon, because I just started thinking of really easy optimizations that would be simple, right? Okay. So, what are we getting? Oh, low FPS. Low FPS. Actually, we could do this. So render mesh which this function that we're working on is called, 7 layers down from or whatever, is called 5,600 times, and it's taking 40 milliseconds, which is a lot longer than, this is still debug build, right? An optimized build would go a lot faster, but you don't want your video game taking this long, right? I don't remember how to reset this too. So render entity is 37. Render mesh. Wait, 48. Hierarchical. How come it shows as less until I expand it? Oh, this is, okay, because this is the portion of render entity that's in render base frame, right? Okay. Because in addition to the base frame, we have, for example, shadow maps and whatever, which are other times that we render entities. To be clear. Do you use Redis bitmaps? I don't even know what that is. How much does IQ matter for getting a highly paid job in programming? I mean, nobody's going to give you an IQ test. What they care about is if you can do the job they're paying you for. Okay. Anyway, so if we see these numbers, we're 40 mid milliseconds in render mesh. If we see those numbers change, that'll be great. But even if we don't, I was about to say this and then I got sidetracked. Even if we don't see a massive noticeable improvement, it's still very, very important to do this, because it's like, when you have so many wrappers around wrappers around wrappers and indirections around indirections, sometimes it takes a while to get the win. Sometimes you have to keep simplifying it and keep hammering on it until you get it to the good state. And if you remove one or two, it's often not enough to get it to the good state, but those were still standing in your way of where you need to go. You know what I'm saying? And confusing everybody and making the code harder to understand and all this stuff. So, but we're going to hope that we can just do this. So all of these should be doable. I'm just going to do some here. Oh, these are all. Oh, and then the quotes. The whole point was that we are not doing the quotes. Hey, look! Our entities are still rendering. Okay. Feels like the frame rate's actually... Well, it was 12 before. but it was 14 for a minute. Okay, so the other problem that we have with all of these numbers is you can't take any of them seriously because this is a dog shit laptop where I can't control performance. Oh, you know what? We're also in balanced mode, which is more automated. I don't know, guys. Like, this laptop, I'm about to throw it out the window. I bought another one already. I've had this one for 6 weeks. It's so infuriating. It just runs things at random speed. When you're on battery, there's often like a 1 second delay when you try to scroll a window and it scrolls. It's insane how bad things are. Like, I just can't emphasize enough how bad things are. Like, okay. Anyway, render entity, I mean, I did just turn up the laptop, so our numbers are basically compromised anyway. We can't really compare anything. I could put it back in that mode, in balanced mode for a second. It's probably under the... It doesn't make much of a difference right now to this frame rate. I mean, the numbers are going down, I feel like. I feel in my heart like the numbers are going down. So we're just going to do all of these. Okay, and then all of these are pointers. Hopefully I didn't break something. Feels a lot faster, actually. We're still in... Are we in balance still? Yeah. Alright, yeah, dude, it's way faster all of a sudden. Like this was 40 something. So we've cut it in half. Now, again, the total number of milliseconds would be much less in release build, but yeah. Why am I not using MacBooks? Because I can't. I'm a programmer, guys. I'm a programmer, guys. I'm looking for a pen. So there's some more that we can look at here, right? Like the set textures, like I said, we have more set constants down here that we should definitely look at. What is it about a Mac that isn't conducive to a programmer? Well, Xcode for one. Now, I wouldn't actually be using Xcode in my own programming language, but it's just an example. Just everything about Macs is Macs are not about making an excellent tool for practitioners. They're about making a computer for people mildly afraid of computers, right? Which is why they did the one mouse, why they did the 0 button mouse actually at some point. And I don't know. It's not good. The thing is, Windows and Linux are also degrading in quality as time goes by. So like, I can't, like this laptop is supposed to be an expensive, high quality tool for practitioners or gamers or something. And it's not, it's a pile of dog shit. So I don't know what to do about this. But using a Mac is not really an option. macOS feels like it's embarrassed to be a computer. Yeah, that's kind of how it seems like to me. Windows is trying to make a kernel-only core version or something. Well, I would maybe switch to that. I mean, the terrible thing is everybody copies Apple. So all the Windows laptops don't have trackpad buttons simply because Macs don't have trackpad buttons. So it was like the single greatest downgrade in usability in a long ass time. All right. So now all of this, by the way, which expands to a bunch of assignments, all of this is just copying data that also got assigned from somewhere else that we could have just assigned directly at the time, right? So yeah, it's kind of not the best, not the best, not the best. Offset divided by entity matrices. Why are you array what? The actual fuck. What the actual fuck? We're doing a malloc per entity right here. Ish. Maybe not that many, because... Yeah, no, we're not doing that many, but still. Okay, I'm getting angry. I'm getting angry. All right. Yeah. Did I write the code I'm currently disparaging? No, I did not. Well, I might have written some extremely, extremely early version of this that has then been edited by like 5 people on the way to where it is today. Like, what the fuck is this? Just allocate the max number of entity matrices we're ever going to use. Yeah, I'm going to have to fix that. Makes me so angry, dude. All right. Like, I pay people millions of dollars and they write this. No offense to whoever wrote this, but come on. This is the core entity render. I could have just been on a beach with millions of dollars instead of making another video game. You know what I'm saying? Do you know? Do you know? I would be bored, but I would just be making one-person indie games. It would be fine. Okay, so this is all working great so far. So what we're going to do is continue till we get this whole function done. And then I'm going to, like we're going to replace these. Then we're going to take the W, and then we're going to fix this, and we're going to take that W. And then we're going to write an explanation of all these things. Like, all this is stupid. Like, we're making this entity matrices. We're memcopying it so that we can memcopy it into the buffer right here. Like, we're dynamically allocating some shit so that we can copy from something that already has the data to something that is already big enough for the data. There's no reason to do this at all. At all. Fireworthy, no. I mean, I don't know. This is just the kind of, like, if you don't stand guard over the engine with an AK-47 at all times, this stuff just happens. Like, rooftop programmers, hell yeah. Hell yeah. Okay. We should not be doing this per entity. No way. Okay. It's actually, okay. There is a non-zero probability that I actually wrote this. I don't think I did. But sort of the thing that happens is you go way back in time and we had OpenGL front end, like, you know, limited at OpenGL 4 or whatever it was, right? And back at that time, we only sort of had this. So the reason this string API made sense at one point was because we weren't going to invest a ton into OpenGL, right? And you don't want to fill your engine with OpenGL constants because then you have to change all that anyway. So it was like, well, you need to look up the parameters in the game. Doesn't need to be high performance yet or whatever. And so originally we did that knowing that it would be a thing to switch off of eventually, right? And I could imagine doing something very sloppy like this very early on to get something working. So if we went and did a blame on this, I would say I would put the chances around 10% that I actually wrote this line. But I don't think I did. Maybe. But like when you start doing rendering for real, you're not supposed to keep doing this kind of thing, right? So anyway, we're fixing it. That's all that matters here. We're also putting spaces. All right. This is a good to do. I am not even going to mess with that. All right. So we have these set constants. Like what? This is also weird because we're getting this offset, which is the number of matrices. Oh no, this is the number of bytes. Okay. So here, this is the array length element, right? And we're just going to replace this with something that sets the bytes. But we can't even do that yet. Because remember I was saying before, we don't even use the array element version. Well, we're using it here. The thing is, we need to add this and this. Oh, wait, no, this is just setting an integer constant. Sorry. So I guess we're putting the object to world matrix. Why is this called object to world index? Set buffer, object to world T, entity matrices buffer. Like, I don't even know why this is happening this way. Isn't that setting an array of matrices? Okay, let's hold on and look at it, right? So this set buffer, I think by index, this is just the count. I don't know why it's called index. But okay. Yeah, this is just the array data and this is the count, right? And I don't know what the underscore T means. Shouldn't it be commented? Yeah, probably. Why do we have an instance count here? Do we even instance? Like, that's confusing. Okay. Okay, we're going to do the set constant first. Right? I'm just going to put this by the other thing. So these are together. All right. we have, I'm going to add 4 things. Blend matrices T, blend matrices index, object to world T, object to world index. Okay, we're going to swap these because that's what order they're in. Let's just see if we can look all those up or if they're weird. Because maybe the buffer ones are like weird and different. I don't know. We're going to find out. Object to world T, blend matrices T. Yeah, so those we need to do some other way. But we can do these right now. So we're just going to have to investigate set buffer. Maybe actually we check in and take the W before we do that, right? Okay. So set constant. We're going to do again set CB, right? And then C dot object to world index, and then this wants a pointer. Right there. And then same. Set CB. C dot blend matrices index. Count. All right. Oh, I only did that up here. Let's just take that. We're using CB for command buffer. Yeah, like we're just getting better frame rates already. Okay, great. Okay, so like I said, I'm going to want to take the W before we do set buffer. It's weird that we don't pass a length in here, which means maybe we're copying the maximum size, which is also slow, right? Because your maximum size is going to be more than you're usually using. Okay. So let me just start. My verbal brain is not really on right now. That's our only no check-in. But I'm going to do my best to explain, and then we'll check it in. Okay, rather than the slow method of setting parameters by name that we used to be doing. We now store the information for these constants in a structure. It gets refreshed every frame, and just use those just use that information, the position, size, etc., to store the data directly without doing hash table lookups or other nonsense. You know what? I just realized this is going to fail if somebody edits a shader and these don't exist, because we don't check for null on the constant. So let me go back here. We have to put an extra if statement, sag, but we're just going to say if this can happen if we had an error looking up the constants. Maybe we should if developer this question mark. Maybe not. Okay, this is already much faster just changing this routine. Saved 24 millisecond per frame in promised one in debug build. Like the amount of quality of life that you get when you shave 24 milliseconds per frame when you're trying to debug something is like, it's large. It's large. But this is the thing. So many of you may have seen Casey's recent video about making code not pathologically slow, like not even optimizing, but just like write the obvious thing that is not going to be pathologically slow. And that's all I'm doing here. I'm not optimizing, right? I'm just like, look, we just know this information, so let's understand that we know the information and then use it, and it gets way, 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 way faster, right? So that's about all you have to do in modern programming to be considered an amazing programmer by everyone around you, because nobody does this anymore. Like nobody has enough understanding of the program or the data or the situation to even know what these things are that we know. So yeah, common sense elimination of clearly bad things. Yes. Okay, this is just one step of many that need to be taken to simplify the renderer. Why are we storing stuff in an entity parameters struct in the first place? Why don't we just put those values directly into the target buffer in Simulate? Why are we calling this function n times per frame per entity, one for each pass, when all the data here is constant across passes except maybe one transform? Why don't we just store the buffer store the target buffer on the entity for the duration of the frame, and just reuse that data. Okay. That's probably enough of an explanation for now. I don't know. All right. It's just programming is so frustrating like this because it doesn't seem that hard to me to know how to make things reasonable. Not even like awesome and optimal. We're not talking about Mike Abrash's 7-cycle texture mapper, right? We're just talking reasonable. And it just doesn't happen. Like, I don't know. It's so frustrating. Okay, and again, I'm complaining, but like, we're a video game company that makes relatively good things. Like, almost every other software company in the universe somehow does a far worse job at this. So, dude, I don't even know. I don't know what to think about anything. Okay. Part 1 of my angry entity rendering revamp. I am pretty angry. Okay. So this is pretty good. We just took the W there. Now we want to look at set buffer. The set texture we're going to have to look at as well. But let's do the set buffer because I want to get rid of like this giant trash can right here. Did I ever do more work on the slideshow program? Maybe a little bit. How do I know what videos you saw? How do I even remember what videos I posted? Like, I've used this slideshow program in like 25 presentations. So I kind of want to make some golden monkey tea, but I also kind of want to be able to sleep tonight. So I'm going to make a caffeine-free tea. Do I feel as productive when streaming? No, I definitely take a productivity hit usually when streaming. I just do it to help spread information. Like, you know, people are interested in this kind of a topic, right? And all over the place, you see these APIs where you set parameters by string name, and it's very slow. So I figured this would be a good thing to stream. We're just going to convert it to a different thing, right? And that's how it's going to work in our engine. So, and I wish I was less ornery right now and upset, but that's just the way, like sometimes just things build up for years and you're thinking in the back of your head, why does this suck so much? Like for years and years of, yeah. And that's, like, it feels good because there's a release of this tension of like, oh my God. But again, it's only like one layer of like 5 layers that have to happen. Okay. So Karma Action Stream is AGI programming. I would not recommend anyone to stream if they are not super motivated to do so. It could be a very frustrating experience. That's all I have to say about that. Okay. Yeah, let me get some water boiling. I do want to emphasize, by the way, when I get grumpy like this, it makes me sound like I, am in a very negative scenario. It's actually not true. Like, a lot of this code is pretty old and was written during a time when I was very unhappy with what was going on. But right now, actually, I think we have the best team that we've ever had by a significant margin, actually, and I'm very happy with how the company is going now. So I just want to say that, like, we've got a good team and we're doing good work. It's just, there's just also cruft that we have to hammer on. So not everything is negative, not everything is sad. It's actually pretty good. It's just, okay. While the tea water is boiling, I bet set buffer is in here too, right? So same thing, we have mappy. We know where to get mappy, except when we looked it up, it didn't work. Oh, that's in resource map. That's a different place, right? So our other thing is in map. Resource map is different from map. So we could do this. Let's just say resource map. Some stuff is stored in resource map and other stuff is stored in map. Why? Not sure. Maybe it is something we should simplify. Okay, we're just going to go table actually the resource map is probably a different type, huh? Resource map table from U32 to a resource info. Yes. Okay, that's why. So for now, we're just going to do this. Wait, that's okay. No, this is totally different. All right. Okay, this is a bummer. This is a bummer. Well, it's not that big of a bummer. It's also not a constant, so I have to think a little bit more. All right, my tea water is boiling. Toward and positon. True. Positon. I don't see positon, so maybe I deleted it. Okay, this is kind of dangerous. We are trying the pumpkin pie chai, which is caffeine free. Who knows where that's going to go? Who knows? Okay. Resource map. If it's in resource map, we're going to say, oh, shoot, dude. I deleted table. We're just gonna undo. Okay. So this is this. It's just a resource info stored in the hash table. But that just gives us an index. Maybe that's all we really need, but let's see. Or set buffer. Wait, we're literally okay, so buffer is like a pointer to a whole other thing that we're going to have to figure out. Okay, so anyway, when we look at this one, we want shader binding set, which God only knows how we even get there. But we have the mapper. We have Mappy. right? And then we're looking in the resource map and we get the info, right? So we're going to do that again. Here we'll put this down there. Unable to find constant resource, whatever. Okay. This is just going to have an index. Type of resource info.index. Actually, it's not even a pointer. We might not need the note because if it's a pointer, it's going to be one of these. Otherwise, it's going to be one of these. All right. Resource map. So this is info and found, right? And then we're just going to say set. We don't know what set is. Oh no, we don't do that. Sorry. No, we just say type of resource info.index. Right? Cool. Resource info is not even a thing. All right, so resource info is shader bindings and mapper. All right, so we're just going to say, instead of all these type ofs, we're going to say replace this with resource index. P is used before its declaration. What? Oh. Yeah. Can't move it all the way down there. Can't move it all the way down there. Okay. Oh. 0. I don't know if 0 is even the null value. Info.index. Attempt to dereference type use 16. Wait, what? What line is this? 1867. What? Info, comma, found is table find. Oh, I didn't put resource map. All that. Resource map is not, oh, because that's constant buffer mapper, but we need wait, no, that is constant buffer mapper. What? Shader bindings mapper. constants buffer mapper, constants buffer mapper, shader bindings mapper. Okay, so now now I get to figure out how to get the shader bindings mapper from, I feel like I'm programming in Java. Okay, I made too much chai. It is filling it all up. Okay, so we got the shader bindings mapper from the shader bindings instance dot shader bindings. No, we don't need the set. No, that, okay, wait. Yes, SBI dot shader binding. This is weird because we're using this here, but not here. Okay, so we need a shader bindings. No, because the instance is going to be pointing at the shader binding. Oh, is it just literally no S? So that's a case where if our compiler had the thing where it's like, maybe you mean whatever, that would have saved me a minute. We don't have that. Just saying. We need the Kathy Newman bitmap. What you're really saying is shader binding mapper. Okay, so that works, obviously, because we wouldn't really see anything if it didn't. Okay. Why don't I just have ChatGPT write the whole video game? Dear ChatGPT, please make a video game about the really interesting way that game mechanics combine combinatorically. See what it comes up with. Okay. So, oh, well, okay. So we're not spamming, which means we found the buffers, but we're not using them yet. So forget what I said about obviously that works, because we're not using them yet. We have to go back here, and here, set buffer. Dude, there's so many levels of indirect. There's so many set buffers, right? Oh, no, there's only 3. Okay, so this must be the shader bindings instance one. We're going to make a capital set buffer. Like, I'm just going to copy all this down here, and we're just going to attack it. So this is the shader bindings instance. set buffer SBI shader bindings instance index resource index buffer pointer buffer. So what entity matrices buffer? We're gonna have to like even investigate that, but again, one battle at a time. Don't you love it when parameter order swaps? We have name buffer and then buffer name. Okay, I do that sometimes too, but I try to clean it up when I do it. Okay, so mapper location. No, not location, because it's index. Oh, but we need the info. All right, let's just... So yeah, so instead of storing the index, we're going to store the whole info because fuck it. So we're going to go info is resource info. All right. I already can't find how to get set. Set buffer. How do we get from this SBI.shaderBinding set? All right. Set buffer. Okay. Okay, set buffer. Right, so this object to world T we said needs to be the info. This is going to be resource info. All right. I think we just do this. And info. Probably forgot some. Oh, probably forgot some. Yep. Oh, yeah. Boom. Name. Could not set. I mean, all right, now we are actually setting that. Could be a complete disaster. Nope, we still see the dude. So this, let's go back and show that code. This is literally, oh, well actually, this is the thing that sets the world space coordinates for everything. So if that didn't work, it would be such a giant disaster. All right, let's do that here too. Blend matrices T. Entity matrices. Like, yeah, I don't understand the logic there, but okay. Okay, guys. Hey, look. I mean, we only removed 2 more hash table lookups, but like, look, we're down below 20, right? We were at like around 23 for render mesh. Now we're at 19. It was at like 44 or whatever, 42 in the beginning. Yeah, okay. So I guess I take the W again. Oh, you know what? Yeah, let's do this. I don't want to swap these around. So then we can get rid of these notes, and that's less error prone for when people are just doing the declarations. Oops. Yeah, render entity. Render mesh 18. Okay, so all right, well, we're going to take the W there. Actually, I'm going to be responsible and do a Benny test because, well, we have done a lot of stuff, and it's possible that I've introduced instabilities. For example, if stuff gets hot loaded in the middle of the frame and we're no longer doing the lookups, like, really, I should do the hot load switch over by the end of the night. Just to be safe. Because there is this weird thing where I'm caching at the beginning of the frame. Oh, but you know what yeah. It's only for this one shader, so it should, in theory, always have happened by that point. Okay, we got to turn up the speed here. Test time rate 150. How's it going, everybody? You know, when people always ask, why don't you make the tests not render? Because we're testing if the renderer crashes. You know what I'm saying? You know what I'm saying? What the hell was that level? Fans. Yes, fans go Burr. Fans go Burr. Okay, this is obviously broken. So one of the people we hired just recently who is, first couple weeks at least, you're mostly getting up to speed and learning the game and the code base and the programming language you've never seen before. But we hired someone to sort of focus on visual effects programming. So all the goofball, temporary particle effects that don't look good, hopefully will start looking better, and that'll be cool. And we actually have someone else who sort of started part-time a while ago but is going full-time soon, and then probably will also be doing some of that kind of thing. Hard to say. I need to make these checkpoint and fade in and fade out flashes just like go faster and speed up. How much faster if you didn't refresh the constants all the time too? Oh, I know. This thing that I just did is just step one in making it faster, right? There's several more steps. Several more steps. How do you find good programmers? It's really hard. There aren't that many. There probably are in absolute terms, but they're mostly hired by other companies at any given time, right? And so the actual available supply at any given time is not that many people in absolute terms. Oy, oy, oy. What is better from the company's perspective, employer, contractor? Probably, I don't know that it matters that much. It's a lot less of a hassle to have contractors, though. I would rather that most of the legal crap involved with employees went away and most of the health insurance crap went away. Just let us pay people and they can pay for health insurance, right? We would pay them more because we don't have to pay health insurance, and they can decide whether or not to buy health insurance, right? The fact that that's not how it works is a clue that some serious corruption has occurred. It would just be so much better if I could just give people money and then they could spend the money on whatever they want, including health insurance. It's so obvious, right? I mean, it sure looks like the renderer is not crashing. That's good news. We should also open the editor. Fewer people would have health insurance if they had to pay for it out of their bank account. That is true. It would also be cheaper, though. Like a lot cheaper. And the reason fewer people would have it is that they would be making the actual choice of what they value, right? The whole point, the reason the company thing is a scam is it's to override people's decision making about what they value. Would they rather have $1,000 a month or health insurance, right? In fact, it's even more than that right now. Like a lot of our employees are like $2,000, $2,500 a month for health insurance. It's insane. It's like rent level costs, okay? Would you rather have $2,000 a month, or would you rather, like, oh, sometimes when I go to the doctor, I only have to pay $20 instead of $100, 3 times a year or whatever. Like, it's stupid. It's stupid. And it's kind of why the USA is starting to fail as a country now, right? Is we have too many of these things. Like that one thing is not so bad, but we just have too many of these things all stacked up, eating all the productivity, and or most of our so-called work hours are not focused on generating actual productivity. So we have problems now, It's not a surprise. Some of your providers stop taking insurance and just take cash direct and it's cheaper. Yeah. Yeah, I mean, yeah, that's the thing is the providers also have giant bureaucracies that they employ to try and not ever pay claims, right? So like, it's like Fight Club was a documentary. Although that was life insurance, not health insurance. Okay, so we did the responsible thing and, oh wait, what did I say we also wanted to do? Open the editor. Look, the editor works. Do 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 do. That was a weird rotation, but delete. Easy clap. Okay, so if we're going to get complete victory over this function, we now need to look at set texture. Okay, so let's look at set texture. Shader bindings instance, shader bindings set, name texture. Shader param hash, Resource map. Okay. So it's the same thing as what we just did. So we should be able to do light map and light map L1. Like that. And like literally, I mean, we should just be able to use like set buffer almost, except okay, let's leave these here for a second unless we need them back. So I'm going to make a set texture, although seems like we might not need it. Okay. Set texture. So we get the shader binding set here again. We already have the info. Okay. I mean, that is pretty much an easy clap. No, not release build. I mean, I see textures. Do you? Well, light maps. Hold on, light maps. Light map mode is what? Oh, maybe this level doesn't have light maps. Hold on. Or maybe we screwed them up. That's possible.
I'm free.
Light map. Oh, there we go. That's light maps. So, yeah, it looks fine. Some levels just haven't been baked out with Z light maps. Frickin' Putty steals the backtick all the time. Okay, I mean, sure seems like an easy clap. Okay, I think we didn't check instance before set buffer. Boom. All right. So we have complete victory over the assignments, but there is this bull crap in here. So we have to finally understand this. So we have entity matrices data, which is like, is this a static entity matrices data? That's a global ass array. Like, what is even happening right now? Why don't we just have a max on this? And we're the insane thing is we're resizing it. So if it gets big, well, I guess that doesn't deallocate though. Never mind. I think it doesn't deallocate. Okay, but you don't want dynamic allocations in the middle of a renderer at a place like this when you don't need them. Like this should just be like a frickin' 5,000 and whatever. Okay, but like I said, maybe we don't need it, right? So we're resizing the entity matrices data. So, right, this is a global array. We're mem copying. Oh, from instances. Okay. And then, okay, so here's the weird thing. Is we're then putting the bone matrices after. The only reason I can think of that this was done was in a weird attempt to reduce the total number of bindings. But it increases overhead because we're doing this temporary copy to concatenate all this shit. Like, I have the feeling we're going to undo all this eventually. Like, it just should be, here's the bones. Here's the instances. Right? Like, saving one binding here is not the play. I'm dying to see what this allocation leaks to do does. It tells the memory leak detector not to report that. Okay. So we're concatenating these two arrays into one array. And then we're calling set buffer with the address of entity matrices buffer. Okay. Which I guess like we have to be blocking on this, right? Like this can't be good. Oh shit. Are we? No, we can't be. No, I don't know. Let's. Oh my God. Oh, no, we're just setting the count. So I guess the idea is the reason you have a buffer is that right now we're putting data in this command stream packet, and maybe you don't want that to be super, super big. Be nice if there was some comments here explaining that. But that is my guess. My guess is that you're like, oh, well, if we've got, one 4x4 transformation matrix is, that's 16 times 4 bytes, right? That's 64. Is it only 64 bytes? Yeah. Okay. And then, but you might have like 500 of those, or let's say 1,000 of them. So it could be 64K of data. And maybe for whatever reason, we just don't want that in these command packets. Right, so we put it on the side. But the thing is, because we're resetting this after every entity, we must be copying it again anyway. So I'm trying to, so we set the buffer, right? And then we say, what was it? Commit entity, no, commit. What were we just seeing? Entity matrices commit. Submit command buffers. Make sure that this is initialized and points at the thing. And then we call update buffer. Which is just a mem copy, I'm sure, right? Render DX12. Dynamic buffer, update buffer. Is that the only one? I thought there was another one. No? No. Okay. Data has been uploaded. Allocate and mem copy. Like, what the shit? We're copying it and buffering it just to copy it and buffer it again. This is what I'm talking about, right? I'm going to delegate this one to the dude writing the DX12 backend, because he would so I'm going to write a comment in the code about what I would like to be done, but I don't want to mess with this stuff right now. It could be very easy, but at some point, here's the thing. I can do this stuff all day, but at some point, I want to get the team all doing this stuff, right? And so how do you do that? Is you make an example of like, here's how it should work. And then you want that example to propagate through the code. And so it may be time to start doing that. Okay. Here we go. Here we do dynamic allocation at runtime and make a whole extra copy of this entity of these transforms into global variables, just so that later on we call update buffer and copy them out again. This seems to me like a historical layering of junk that is no longer applicable. What should happen here is that we directly call update buffer with the data from instances and blend bone matrices. And this is the reason, the one reason, if it was just this part, I would do it right now, but it's also like, why are these two things packed into the same frickin' thing? And like, let's split that apart. We should directly call update buffer with the data from instances and bone matrices. And completely skip all this entity matrices, commit stuff, entity matrices, the global variables entity matrices buffer and entity matrices data should just not exist. Yeah. Part of what's going on here is that the instances and bone matrices are being combined into one array. For what reason, I have no idea. Maybe someone long ago felt that it was a good idea to have one fewer binding in the shader, but this doesn't make sense to me given the large increase, the added inefficiency and extra code complexity of concatenating these arrays and doing all the entity matrices stuff. This just seems like something that once upon a time was intended to be a temporary hack, but then people took it seriously, and now we are where we are today. Okay. So the first step, is probably to split instances and bone matrices into separate arrays in the shaders, which probably makes those more readable too. Okay, so that is my explanation for the team about the thing. And really we could shut it down there because it's been a massive win tonight. Aren't I sending the whole matrices buffer duplicated when you bind set the bones buffer? Maybe you mean this is a little weird. Actually, isn't there a big inefficiency? Oh, no, it's not actually. So the thing is that commit entity matrices function is what actually does the copy. It doesn't happen at the time when we're doing all the other data down there. It happens at a different time. When we're done, like when we're submitting our command buffers for some reason, like this thing should not care about entity matrices at all, right? Yet it does. So this is the thing that does that. So binding the buffers does not do the copy. Yeah. No, I understand. I understand what you're saying because it seemed to me like that might be happening too, but it's not. But either way, like, dude, all this is about is putting some data. We're just trying to put the lotion in the basket. You know what I'm saying? Like, it just isn't that complicated. So if it ever gets confusing enough that you don't know what's going on, then probably you need a better basket or some nicer lotion or something. I mean, really, isn't that basically all programming is just about putting... Look, we're almost up to 20 FPS, guys. We were getting 12 FPS in debug build at the start of this, okay? Render mesh is down to 15, right? So our savings is around 28 milliseconds or so per frame in debug build, right? Maybe a little more. It was like 43 in the beginning, right? What's 43? It's 27. Yeah, 27. 44, 28. Yeah, that's fine. Now let's just make a release build. I didn't notice before what the frame rate was, but we'll just do a release build and look at it. Nintendo Switch performance numbers. Yeah, and like we were saying in the beginning and also in the comments, there's still way too much overhead going on. Like, every time we render an entity, there's a billion if statements that happen. And then we fill out a struct called entity parameters. And then we copy the data from entity parameters into this buffer, right? And we do that for every rendering pass. Like every shadow map and entities in and all that stuff, even though it's the same data every time. Like, we do so much extra work. And this is why I've just been... like, the frustration has been building because I want this engine to be super awesome. And it should be. And it is. Parts of it are. But, like, this part hasn't gotten there yet, right? And so I'm hoping some other people can do some. Like I said, now that we have the best team we've ever had. Yeah. All right. So we're getting like 50, 60 something, 40. It's highly variable for some reason. It's either the laptop's fault or our fault or both. But you know, so render mesh here is like 4 milliseconds. Of course, I didn't bench what it was before, but already, like, okay, people in the web world think 3 milliseconds is a small number, right? But that means as soon as you're saying it takes 3 milliseconds to render meshes, that means your maximum frame rate, if your game does nothing else, like doesn't even actually draw the pixels and just sends the data to the GPU, your maximum frame rate is 333. And it only goes down from there, right? That's actually very bad. So 3 milliseconds is a long time. You want that to go down. I think it can go down by a factor of 10 still. At least. Like, we'll stop at a factor of 10 because it'll be good enough for a while. If it's a 2D fighting game, it should ideally be 144 hertz. Right, like, let's say, so I have a 240 hertz gamer monitor, right? So as soon as you say it takes 3 milliseconds to render meshes, you almost can't hit frame rate on that gamer monitor at all, right? Because anything else you do is going to take up that remaining time. Undertale is locked to 30. That's because they need all the GPU time to do the awesome graphics on the skeletons. 3 milliseconds makes that big of a difference? No, do the math. 1 second is 1,000 milliseconds. All right? So divide 1,000 by 3. That's how many times in a second you can do that thing. The answer is not as many as you would like. Milliseconds are a really long time on computers, especially year 2023 computers. If anything takes a millisecond, it's doing just an insane boatload of incredibly heavy work. On the website, sending data from Germany to the USA, for example, it is not a lot. Yes, it is. It is a lot. It's just web people are not good at their job, so they don't know that 3 milliseconds is a lot. That's all that's going on there. I've been disrespecting seed oils for several weeks, but I've been finding good snacks to have. So, for example, these chips, sea salt and vinegar chips, which are really delicious. They have palm oil, which is not as bad. Be better if it were coconut oil, but I think since I've been good, I get to have some ice cream as well. Because I did good right now. My freezer is too cold, so I have to take out the ice cream and let it thaw a little bit. Are there any questions about the optimization work that we did here? It's not even optimization. As Mike Acton said, we were getting the clowns out of the car. There are still a lot of clowns in the car. All right. But we're doing good. Any questions? This is all wins largely from eliminating string hash table lookups. Yes, that was the whole point. So the whole thing, you can go see more detail if you go back to the beginning of the VOD, but every time we render an entity times every pass in which we render that entity, we call a render mesh function, and that render mesh function eventually does a lot of other stuff, half of which it shouldn't do, more than half of which it shouldn't even be doing. And then it eventually calls add entity component, which fills out all this data, which is necessary to draw any entity. And it used to be a hash table lookup for everyone, including hashing the string name. Like that wasn't even compile time. So now we skip all of that. We know the exact target location for the thing, and we set it. And it's a massive win. Speed of light demands 25 milliseconds one way. There's a difference between latency and throughput, my man. Does this game have graphics settings? Yeah, it does. We're just not being too serious about those right now. Like usually games finalize what those kind of settings are like at the end, because that's when you know how expensive the various graphical operations are, and that's how you know how to dial them up and down, right, based on what you're trying to do. Do I know why it was a hash table before? Yeah, I explained that earlier in the stream. You could go back and watch. It's essentially the lazy thing to do. So that's what happens, right? What's the next clown I'm planning to take out of the car? Well, this is more of a mess thing than a speed thing, but I wanted to get rid of all these reload if dirties. Like there's literally 113 of them. I'll probably do that next. We'll probably have some ice cream, and then I'll at least attempt this. Right. There's two. There's reload if dirty on a shader, and then reload component if dirty. I'm not actually sure what the difference is. So we're going to have to look at that. I'm going to turn down the laptop performance so that Fake milks have a lot of oil worth disrespecting. That is true. I don't drink fake milks. I never like them very much. But I especially stay away from them now. Like when you look at what's in them, oh my God. This is the thing, like, one thing that you should have a refined sense of as a programmer is it should be kind of painful when there's code doing a ton of things that it shouldn't be doing, right? Like, if you get a sense for that, you will go far. And a lot of people don't seem to have that. When I say something was done lazily, I didn't say something was done lazily. I said it was the lazy thing to do, which is different. Like looking up the string name in the hash table is the lazy thing to do because you just do that one thing and you know you get the right information there. Now it's a lot slower. But like you don't have to do what I did, which is like declare somewhere else a place that holds the data and then look it up in a separate phase, right? There's a sense in which the code looks simpler if you just do this. But the problem is the code's not really simpler in a different way because then this thing that should just be put these 8 bytes from this memory location to that memory location, right? Instead of that, it becomes this whole production that you have to step down into just to put 8 bytes from this memory location into that memory location, right? And from that standpoint, the code is much more complicated. It's like the thing that Casey was pointing out in Python of like, here's everything that happens when you say plus in Python. It's really complicated. Any other on-topic questions about what we were doing here? Ice cream. Okay. Since the ice cream is still thawing, we will start on the thing. How close do I suspect I can get the debug renderer to the production render performance-wise? I mean, there is no debug render. Do you mean the debug executable? It'll still be pretty far. Like it's a debug build of a program. Like we don't want to spend necessarily a lot of time optimizing the debug build, but when the debug build is especially slow, it does get in the way because it takes a long time to do things and you can't really play the game the way you want to and stuff. And so it is bad for it to be super slow. But when we actually optimize, we care a lot more about the optimized build, you know, the final release build performance. Okay. So let's do the okay. Recompute sky, recompute on, okay. Reload shaders if dirty. Okay. So here, I'm going to copy pasta this function. Okay. This one, oops, did I actually delete it? What is even going on? Okay. Bro, Emacs is so confused. Just a little bit more visuals. Okay, so here, we're just going to make this not do anything. All right? Because I don't want to go and do a bunch of tedious stuff on all the calling sites yet. We'll get this to work, and then we'll delete all the calls to it, right? And how do we get it to work? Well, we're going to just write our new thing that does this all in a batch at the beginning of the frame, called once per frame at the beginning to check for dirty shaders and reload them if necessary. If necessary, this way we don't have to have a bunch of crappy calls everywhere to check for shader dirtiness like we used to. And we also don't have to worry about shader constants changing location after we cached them at the beginning of the frame. Okay, so reload shaders if dirty, pretty easy. For catalog dot table value key in shader catalog dot table, right? The key is a string. No check-in reload if dirty was the value of shader. Hold on. Shader file. Fuck. Shader array at speed, should we put a dirty flag on shader file so we can skip this iteration if it's not set? Reload if for shader file dot. Oh, we could also reload component if dirty. Shader array. Shader. Okay. So now, do we have... That's just in iProf, I guess. Oh yeah, okay, so we just no release build for now. Are these constants being pushed to a UBO? You're thinking of a very OpenGL specific concept. It's not quite the way that modern APIs work, but in essence, that's kind of what's happening, yes. Okay. There's a file scope. All right, so scope export. Wait, what? Oh, I was looking too high up. Shader array is not a member of shader file. Really? I was looking right at it. Oh, shader variation. Oh my God. Okay, for variations, shader file dot variations array. Okay, and then nutballs. Are there good resources I'd learn learning modern graphic APIs? I don't know. There might be. I did not learn that way. I have never looked at DirectX 12 documentation, for example. I sense a disturbance in the force. Bro, we're reloading everything every frame. What is happening? What is happening? Okay, so the deal is lol. The deal is we're loading everything that was ever requested by any material like that we knew or something. Right? I don't even know. I don't even know. How do we know if something's loaded? Like, why do all these things exist anyway? Okay, we'll check valid. Okay. Clearly, oops, didn't mean to do that. Clearly there is a problem. Well, vanilla ice cream's good. Reload needs to be more tactical, clearly. Clearly. Reload needs to be more tactical. Now. So. This is weird. Oh, you know what? Actually, no, that's probably fine. See, this is ridiculous. Well, maybe not. I don't know. I don't know, dude. So it sure seems like we're not loading a shader. This shader is called error. It's dirty. Maybe we dirtied it in the middle of the frame. Valid is false. Okay. So this is like the initial. Okay. Okay. The initial load is no longer happening. So here's what we're going to do. Return false. So the deal is we sort of demand load shaders in the middle of the frame, but we don't. So the first time they happen, it's okay, but we don't want to like hot load in the middle of the frame. Still didn't work though. Look at all my instances of Visual Studio 2019. Hell yeah. Okay, reload if dirty. Oh, well, if there's no shader, if shader is literally null, like, just return on these. Like, come on, bruh. Come on, my guy. My mans of La Manchas. My man of La Manchas. Hey, look, it works again. Okay, and let's see the hot load working. So, data, shaders, materials, guy. All right. So here's the guy. He's standing over here. Hopefully, we're actually using this material. Output color.r is 1, G is 0, B is 0. And then we stall because shader loading is incredibly slow. There we go! We hot loaded our shader in the middle of the frame. Now the problem, though, is I'm not really going to succeed at... See, if we need to call something the first time we use a shader, then I can't really get rid of this 100 and something calls around the game, right? You dig? You're worried the baby thinks shaders can't change. I know. I know. Worried the baby thinks shaders can't change. Let's change him back. Ta-da! Okay. That's great. Why do shaders take so long to compile? Because we have made terrible mistakes as the game industry. What is the shader language we're using? It's just a shader language we had to make up because the computers are terrible. All right. Every GPU wants to be a special snowflake. That is true. Can you parallelize shader compilation? Not really, because it's all in the graphics driver. What about slang? I don't know what that is. Maybe it wasn't a thing when we needed to do this. Okay, so who calls reload component if dirty? Render frame. Shader component. God, dude. Please. Please. Yeah, some things are named confusingly. That's so like we have a component. We're looking up what variation matches it, which a variation is just like what are the different if-defs and options turned on for the shader, right? Then we free all the components assigned to the variation, which shouldn't that include this one? No. Like, yeah, I don't know. I'm a little confused. Maybe I just need to think about that code a little more. And be more familiar with the data structures. It's quite possible. Supposedly the higher-ish language is a superset of HLSL that's supposed to make most of the shader pain go away. Making it easier to work with shaders. How old is this? I never use GitHub. How do I know? It just doesn't look like very many people use it. Oh, wait, in 1 week. 1 month. Okay. I'm just, I'm sure the code is just massive and way bigger than it needs to be and all that, but how do I see the frickin', where's the little bitmap of all the check-ins? Sure, I'm glad they're crunching the latest data just for me. That makes me feel really good. Earliest commit was 6 years ago. Okay. Well, we probably deliberately decided not to use this for some reason. Whether that was the right decision, I don't know. Maybe we'll switch to it for next game. For this game, I think we're just set with what we have. Repositories 13. All right. Source. Core. Oh my God. Oh my God. Yeah, no wonder we don't use this. Compiler core. Oh my God. Yeah. I mean, Jesus. Jesus. Yeah, we're not touching that unless we have to. We'll see next time. Like, why do you want JSON in your shader? Like, what does this thing even do? Like, what are they doing? What are they doing? NVIDIA developers swear by it for some reason. Well, within a company, everybody always drinks the Kool-Aid, right? Okay, anyway, I'm a little worried because I did kind of leave a little bit of a time bomb in our code about actually no I didn't. Right, no I didn't. I didn't. So when we say reload if dirty, like why is that even an explicit? So like I think we just put this here. Actually, I think we just put this here. See, the terrible thing about this is I remember starting this reload if dirty thing, and it was literally like I was putting it in 3 or 4 places in the code, and I was like, we'll refactor this later when we know better how to do it. And now it's like 100 places in the code, right? This is just what happens. All right, so that's kind of okay. Our frame rate dove off a cliff for a second, but it seems like that was just a laptop being weird, or something. Maybe it has to do with this. I don't know. Okay. Anyway, now the thing is, it seems like we call this a lot. So maybe we can get rid of all the reload if dirties. Like, look at all these if statements that are poorly predictable to figure out what shader we want. Okay, so add frame shader instance. Probably needs to do this. Let's just see if I broke something there. We are just chunking along in the beginning here, good. And then it speeds up. I don't know. This is more of a mess than I want to get into tonight because there's several things happening. There's me wanting to remove all the reload if dirties, but there's also stuff like this where we want to make sure it's loaded, and then if it's valid, we do this. But like, what if it's not valid? Like, all these things should work. Anyway, so I'm going to pause this part of it. Because it's getting to be a little too late to make a major change like the following. Let me make sure, by the way, did the build server like this, what I checked in? Yes, it did. Great. Okay, what I'll do is I'll send an email to the team telling them about what I did. This is really a mess. I mean, it's not the worst mess, actually. Because this is all just kind of reasonable stuff to do. This is not nearly as bad as like setting all your parameters by string name, right? But it is just like, look, if the shader is not valid, that's not something that should happen in release build anyway. So if it's not valid, all these things should just fail or silently not happen, right? isn't a mess to resolve easily. Yeah, it's just, I mean, this is how code is sometimes. Like, there's stuff you want to do, but oops, here's a dependency. You need to do that first. You do that. Oh, oops, there's a dependency. You need to do that first, right? And that's just how it goes sometimes. And how do you deal with it? You deal with it, right? You just do all the things. And it's just, I don't want to do all the things at 11 p.m. when I'm tired, right? And it might be possible that I just delegate these things, right? In the way that I will explain when I'll type the text of the email. So, I'm going to make a buffer for my email. And I'm going to say, after having done the previously mentioned change to entity parameters, I was thinking about how to optimize the rendering code. I was able to form a mental picture about just what needs to happen end to end to simplify and greatly increase the speed of the entity rendering code. I almost never look at rendering stuff these days, so I had been kind of hand waving in my mind thinking sometime we'll get to this, but it has been a really, really long time that all this code has been bloated and bad, longer than most current programmers have been at the company. And I've just had a great deal of built up frustration about how bad it is because I don't know if things go on long enough and you keep telling yourself that someday they'll get cleaned up and they never do. Well, maybe at some point you're fooling yourself and it is just going to stay the way it is forever. This is certainly the fate of many, many code bases. So since I had a clear picture of this in my mind, I decided to go ahead today and take the next step and revamp add entity component so that it no longer uses inefficient string hashing in order to set shader parameters for entities. Here's what the code looks like. And then I can't really paste the bitmap in Emacs, I don't think, so we're just going to leave that out for a minute. This is a commit message? No, it's an email, bro. Mentio end mentioned. Okay. In render frame. Once at the start of each frame, we update the entity parameters. We update a struct that keeps all the required information to set elements of entity parameter C, and here we just use those in a way that is pretty fast. In debug build in promised one, this dropped the amount of time spent in draw mesh from 44 milliseconds to 16 milliseconds, a savings of 28 milliseconds, which is huge for quality of life reasons, for quality of life purposes. Spent per frame. The thing is, this is just step one of all the stuff that could be done that is not even really optimization in any sense. It's just getting rid of obviously pathological stuff, as Mike Acton calls it, getting the clowns out of the car. When it comes to entity parameters specifically, there are still plenty of clowns in the car that can be removed. The good news is that none of this is too hard. I put some further info about next steps in add entity component. Okay. Note that this thing I've done adds new functions for setting constants, etc., and all the old ones are still there, so this represents an overall increase in code size and complexity. Eventually, I would like to remove the string versions of all these setters and just dial down the number of the seemingly excessive number of structs involving shaders, components, instances, etc., etc., because I think there is a lot more code here than there needs to be. One big clown still remaining in the car of add entity component is all this stuff about entity matrices data and entity matrices buffer and commit entity matrices commit, all of which should simply not exist at all. I left a big comment about this. Search for the tag whatever. After the next, I would like to get rid of this. Very soon after the next milestone is done, as a way of rolling forward on the entity rendering cleanup. I'll leave it up to Adrian to schedule this, but it feels to me like something to schedule fixing this is most suited to do right now, since he did the back end code, and this is about directly interfacing with that. Okay. Adrian had suggested during a call today that since a lot of the time code gets written by looking at other code, it would be useful to have a bit of an initiative where we convert other sites that set shaders, etc., parameters, etc., to use the fast way, so that later when people do new stuff, the older examples they look at represent the way we actually want the engine to go. This seemed like a good idea to me, which added to the impetus to my rewrite of the parameter setting here. So I would like us to switch over any code that looked like the old version of set of add entity component to look like the new version instead. That said, there is another issue that has to be cleaned up before we can do this in a widespread way. All over the place, the code calls reload if dirty and reload component if dirty. And this has two functions. One is to respond to hot loading during development, but another is just to ensure those shaders are loaded for the first time because we are going to use them. I started to rewrite this by adding a loop that happens at the start of the frame that reloads any dirty shaders, any shaders marked dirty by the hot loader. Actually, we might already do that. This is better anyway, because it is kind of a bad idea to change a shader in the middle of the frame. Though actually the hot loader would only mark shaders. Dirty at the beginning of the frame, but so nevertheless, why are we asking if it's dirty all the time? There are over 100 calls to these reload if dirty functions around the game, and really they should be it should be called just a few times in some core places. That said, there is a bunch this cannot just be done outright because a bunch of places do this. They explicitly ask if the shader is valid and only do operations if it's valid. I think it would be much nicer if in the case of an invalid shader, we would fail over to an error shader and just have all these operations be ignored. Alternately, we could just replace reload if dirty with ensure shader is loaded. But that leaves 100 plus calls scattered around the code, which I don't think is great for I need to put this where we're going to insert these. I don't think is great for writing high quality code. If folks have an opinion on how this should be structured, let me know. But in general, I want to make these changes pretty soon and am motivated to go attack it. Because whereas I do have a lot of frustration from this code being cumbersome for a long time, that also means that every time it gets one step nicer, I feel a large amount of relief. Okay, so that's a decent length email. That's about everything I wanted to say, probably. Well, everyone, I think that's going to be the end of the stream. I think we did some things. We made our renderer a little bit better. And there we go. Thanks for coming by. It was 4 hours, all in a day's work. Well, it was all in a small portion of a day's work, really. But we got it done. Thank you, everybody. We're not going to raid anyone again because it seems to go badly. We'll try again in a couple weeks. See ya, everyone.